So now let's take a look at the derivatives of the inverse trig functions. So it happens to be that the two most important inverse trig functions that we use, especially in terms of finding their derivatives, are inverse sine and inverse tan. So here we have the derivatives of inverse sine and inverse tan. So the derivative of inverse sine is actually 1 over the square root of 1 minus x squared, while the derivative of inverse tan is 1 over 1 plus x squared. Those are the crucial ones, and so we want to know those by heart. As it turns out, the next most important one is actually the derivative of inverse secant, which is 1 over the absolute value of square root of absolute value of x times the square root of x squared minus 1. And then inverse cosine, inverse cosecant, and inverse cotan are as follows down here. Now, again, these are not ones that you have to memorize. You should know the first two, but the remaining 4 you could always look up. All right, so an interesting question is, why do these derivatives look the way they do? Because they look very strange. That they don't seem to have any trig functions or even inverse trig functions in the derivative. Well, I'm going to show you how we could potentially derive one of these. So consider y equals inverse tan of x. What does that mean? That means that tan y is equal to x. So I'm going to switch to blue here. So if we look at tan y equals x and we want to find dy dx, then that's going to be an implicit differentiation. So if we do the derivative of tan y equals the derivative of x, all right, and then this is implicit now, so the derivative of tan y is then secant squared y and times dy dx, and then that would equal 1, meaning that dy dx would be 1 over secant squared y, but since secant is 1 over cosine, this is actually just cosine squared y. Now that certainly doesn't look like what we've said the derivative of inverse tan is. So now if we actually think about a right triangle, then we see that what we're talking about when we say that tan y is x, so think of that as a right angle, and let's think of this angle as y. All right, so tan would be SOHCAHTOA, opposite over adjacent. So this would be tan y is x, so we could do x over 1. So that means by the Pythagorean theorem that the last side over here is the square root of 1 plus x squared. Okay, so now what I want to do is see what cosine y would be, because that's what's in our derivative there. Cosine would be adjacent over hypotenuse, so 1 over the square root of 1 plus x squared. So now if we go back to our derivative, we see that cosine squared y would be 1 over the square root of 1 plus x squared all squared, hence would be 1 over 1 plus x squared, and there you go. There's our derivative of inverse tan. Now we don't want to do this each time. We would like to know these derivatives so that we don't have to repeat that every time we want the derivative of inverse tan, but that just gives you an idea where it's coming from. So let's take a look at some examples now. Remember, basically all we've done is we've learned the derivative of a function. Everything else still stays the same. So if we want to do the derivative of 2 inverse sine of x minus 1, well, then f prime is, so I have a multiplicative 2. Now the inverse sine of x minus 1, so this is a chain rule, so I'm just thinking, what is the derivative of inverse sine? So that would be 1 over the square root of 1 minus whatever is inside squared times the derivative of that something inside. So derivative of x minus 1 is 1. So in the end, we just get 2 over the square root of 1 minus x minus 1 squared. Now, I could multiply that out, what's in the denominator there, but I'm going to leave it as is. All right, what about taking the derivative of inverse tan 3x? Okay, again, this is really just a chain rule. So the derivative of f would be, so it's inverse tan of something, so 1 over 1 plus that something, that 3x squared, times, now go in the derivative, take the derivative of the something there, and I get a 3. So I get 3 over 1 plus 9x squared. Okay, now if I go down here and I want to do the derivative of x cubed inverse sine of x squared, okay, so what's the first thing I see? Well, I have to identify the structure right here. This is a product. Okay, so the first thing is really a product. Don't be swayed by seeing the inverse sine. That'll come. The first thing I see is I have a product. So I start with my product rule. Derivative of the first is 3x squared times the second as it is, inverse sine of x squared, plus the first as it is, and then the derivative of inverse sine of 3x squared. Of inverse sine of x squared, sorry. So then that derivative of inverse sine of x squared, well, that's inverse sine of something, so that's 1 over the square root of 1 minus the something, which is x squared, squared, times, go inside, take the derivative of what's inside, and I get a 2x. So I would get 3x squared inverse sine of x squared plus, so I get 2x to the 4th over the square root of 1 minus x to the 4th. And there you go.